I'm Joe Perfito. I'm president of Gord J. Gow Technologies. We're the proud makers of tributaries and Clarus products. I'm here today with Greg Hoshin. Greg's our sales team leader, and Greg had some questions to ask me about some of the products that we're selling, and he's online with me. So, Greg, why don't you fire away? What you got?
Hello, everyone. Hey, Joe. We have a few power conditioners in our lineup, and I was wondering if you could tell people why they would need a power conditioner in their either home theater setup or their two-channel setup.
Sure. Most people don't realize the extent of the crud and noise and things that get on the AC line in their house. Our audio systems and video systems are very sensitive to the power supply that's being fed to it. So the AC that's coming out of the wall has to be clean. If it's not, that noise that rides on that AC line can cause problems within the power supplies of these components, and it can change the sound. It can also mask low-level signals and instruments. It can change the sound of a performance. So it's important to get that cleaned up. I guess one of the questions that always comes up is where does this noise come from? Most people think they have clean AC power. Well, it's not the case. The AC power line can get contaminated with things like noise pulses that get put on when a refrigerator motor turns on and off, air conditioning systems turn on and off, dimmer switches, fluorescent lights. There's all kinds of things that can occur to cause put noise on that AC line. That's kind of noise that's in the grid. It can also be noise that's coming into the house from outside, from possibly be a faulty transformer on the pole outside your house or wherever that might be. That's one kind of noise. That's the internal grid noise. Then there's the noise that gets put on the line from electronic magnetic interference and electromagnetic interference. That is EMI, and also radio frequency interference, RFI. And that's things like cell phones and TV and radio stations, all these very high frequency signals that can get onto the electrical system in your house. And the reason that happens is because most homes are wired with Romex, and Romex is an unshielded AC line. So it's copper wire without a shield. And because it doesn't have a shield, those high frequency electromagnetic signals can induce noise into the line, and that noise can be obstructive for good listening. So it's really important to have that. Another source of noise could be other components. Sometimes these components that we use in our systems, especially, most all of them have chipsets in them, and they're little computers. And those computers have clocks, and the clocks oscillate at very high frequencies in the megahertz range. And those high frequencies can leak out of the power supply and through the power supply and into the AC line, and that also can contaminate the AC line. So a power conditioner really is an important piece of equipment for anyone's home theater, either listening system or home theater system, where there's video in play. So power conditioners are a really important part. Now, Clarus has presently has two different power conditioning systems, the Concerto and the Duet. The Concerto is a full-size 17-inch piece that will fit on a shelf, and it has 8 outlets on the back. It has a visual presentation on the front with a voltage readout and also some indicators on the LED indicators showing that the analog, digital, and high current outlets are operational. The importance of the Concerto is the design, and the design is something very unique. The design was accomplished by Jay Victor, who is the patent holder for the Clarus Cables. what Jay did with this unit was he designed it so that the outlet pairs are labeled as analog, digital, and high current. And each of those outlet pairs are connected to filters that are specific for that type of equipment. In other words, the analog filter system for the analog outlets is different than the digital filters that are connected to the digital outlets, and that's different from the high current outlet systems. So the filters in them are very specific. The analog filters are using what are called common mode filters, and these common mode filters work best with analog equipment. The sound is best using common mode filters on analog devices, and that would be mostly preamplifiers. The digital systems, whether it be a DAC or whether it be a processor or some other digital piece of equipment that processes digital signals, that gets plugged into the digital outlets, and those digital outlets are using what are called differential mode filters. And differential mode filters have very specific characteristics that are different than the common mode filter used on the analog system. So this is specific. Now the high current section, that is an analog filter, so it is common mode. But in this filter, we're doing something that's very special. And that is we're using a very high tolerance current inductor. Now, most power conditioners don't use inductors in their high current section. And the reason they don't is most of the time, inductors tend to limit current flow. And the reason for that is most of the time, the inductors that are being used are very small and have very low current capability. Well, what we've done in our unit is that the inductor that we use in that circuit is a 30 amp inductor, twice the current capacity of the concerto, which is a 15 amp unit. So we have a 30 amp inductor. It's not going to limit any current flow for the connected devices. Now, what happens is most manufacturers, if you look at their circuit diagrams, or you look at their, if they tell you about it at all, the high current or amplifier outlets on the back are connected to a circuit that either has no filtering in it, or they're using capacitive filtering. Capacitive filtering is fine, but it's very low-level filtering, and it doesn't do a whole heck of a lot. The best filtering systems for these types of signals are inductive in nature. And the reason that these inductors that we're using are so efficient is we're using a core in our inductors that are very special. They're only made by one company in the world, and they use nanoferrite crystals in that core. And that core can produce a tremendously high level of permeability. That is the ability of the core to conduct and develop a very strong magnetic field. I mean, the magnetic flux in that core is at extremely high levels. Well, that's what determines what the level of inductance is. And because of that high permeability, the inductor can develop a very high level of inductance, which gives it that ability to do a very high level filtering in terms of the 50, 60 decibels of filtering for these amplifiers. And I don't think anyone else in the industry has a filtering system for high current that will allow that type of filtering systems to occur. So all in all those filters, what do? Well, basically they're going to take all the noise that's on that AC line and remove it. And also it'll block any DC that might be coming in off the wall that might be on that line. And thirdly, it's going to remove the veil, the masking that occurs on low-level detail or low-level music detail that you don't know is there until it's removed. And when that veil is lifted, the detail becomes much more apparent, and there's parts of the music, things in the music that you have never heard before that become very apparent. The other thing it does is it opens up the sound stage, both left to right, top to bottom, and front to back. The focus, the ability of the system to produce a coherent image is dramatically improved, and it also produces a very stable image. So the concerto can produce very high levels of performance. It also has an under and over voltage system, so that if the voltage goes over 135 volts, the unit will shut down until the voltage drops to 130, back to a safe level. And also an under voltage, so if the voltage drops below 85 volts, it will shut down until the voltage comes back to 90 volts, and then that unit will turn back on again. It has surge protection in the form of thermal MOVs, and it will protect it against any surges that might occur in the system. The front panel will show delays for turn on for the outlets for the digital and the high current, and it will also show delay and turn down of the system. So that's a basic concerto. That's what we've been able to accomplish. Now the duet is the second unit, and that's basically the high current section removed from concerto and put into that separate section called the duet. So that's basically a 2-outlet unit, and that unit is basically designed for monoblock amplifiers, powered subwoofers, and powered speakers. Those amplification devices that are normally plugged into the wall because they're too far from the main system to get plugged into the power conditioner. Well, plugging them into the wall, of course, then you lose all the benefits of having any kind of conditioning. So it's straight into the wall. While using duet now have a way of protecting and also processing and conditioning that AC line for those 2 units. Now the suggested retail price of the concerto is $3,600, and of the duet is $1,250. So that's it, Greg, for 2 units.
Great, that's really good information, Joe. I appreciate it. I do have another question for you. We recently replaced the connectors in our Clarus line, starting with Aqua. Can you tell us a little bit about the advancements and the changes that we made with those connectors?
Sure. What we did was we changed all the connectors, RCA, XLR, spade lugs, and banana plugs on our Aqua series, and the spade lugs and banana plugs on our Crimson series. The difference is we're using, well, there's a number of differences. One of the differences is that we are now using a new type of copper, 2 new types of copper in our connectors. One is called beryllium copper and one is called tellurium copper. Now these copper formulations both are very high conductivity, but have specific features that make them great for these types of connectors. First of all, beryllium copper. Beryllium copper has a spring to it that standard copper does not. So that means when you move it from one position to another, it tends to want to go back to its original position, which is perfect for things like RCA connectors and banana plugs. The outside grounding section of the RCA is made from this beryllium. So the grounding sleeves around the outside of the center pin, that when it's plugged in has a nice spring to it, so it grips onto the RCA receptacle. Now the center pin is using the tellurium copper because it tends to be very strong copper, and the pin now is hollow. So it has to be strong because it doesn't have the thick wall that we had on the solid pin. But what we found is that the hollow pin is just a better sounding connector. It produces a better sound. And that has to do, we believe, with the control of eddy currents that occur during the playing of this musical signal. The XLR connector uses the same tellurium copper and hollow pins, but now we've done something a little different with this one. On the female XLR, pins 2 and 3, which are the signal, the plus and minus signal, are recessed, where pin 1, which is the ground connector, is flush with the outside of the connector, top of the connector. And what that does is it provides a method of connecting and disconnecting if the system is hot or on, without having any pops or pows or things that could damage the speakers. And the reason that occurs is because the ground is connecting first when it's plugged in. So the ground is connected, then the data signal connects. And when it's disconnected, the ground disconnects first. So the possibility of having these kinds of pops and clicks are removed using that. Now on the speaker connectors, the banana plugs for the BFA plug, that is using that beryllium copper, so it has a nice spring to it, so that when the banana connector is plugged in, when it plugs in, it compresses, and then as you release it, it tends to want to go back out and hold very tightly into the connector. Plus, it's also a very strong copper, so the BFAs have always had the difficulty of being fragile. Well, these tend to be very strong, so they're much better for the application that we're using them in. The spade lugs are also using the beryllium copper, and these new spade lugs now, they are a two-part spade lug, so they're actually in a sandwich configuration, kind of like this, where it's hinged on the back, where the U is on the front. So the speaker wire will come in from the front, and you put it into the connector. Because the front isn't connected, there's some spring to it. So when you're tightening down on the connector, the spring is pushing back up on it. So it makes it easier to tighten down on the connectors on the back of the loudspeaker or on the back of the amplifier. These are all the new connectors. Again, they're complete on the Aqua series. Those are all shipping today. We are shipping the Crimson spade lugs and banana plugs. We won't be replacing the RCA and XLR till probably later this year. So that's it. Those are the two connectors. So that's it, Greg. Well, thanks for helping me out with this and asking all the right questions. And I'm going to sign off now. And
Thank you, Joe.
And right, we'll see you at work.
Excellent.
Okay, take care.
Right.
Bye.